The basis of general relativity. Now, Einstein had a thought experiment, otherwise known as a Gedanken experiment, in which if you are standing in an elevator, all you see is, and the doors are closed, all you see is the elevator, and you feel a gravitational pull. You feel the normal force pushing up against your feet, which you feel is basically directly proportional to your weight. Now, imagine that in this elevator, the elevator is actually in a gravity-free situation, but the elevator is accelerating at, well, for humans, roughly 9.8 meters per second squared. So, is there any difference between those two situations? Because in an elevator that's accelerating at 9.8 meters per second squared, in the absence of gravitational field, it would feel the same to you as if you were standing in an elevator here near Earth. So, if there is no difference, Einstein then took first leap and he said, there actually is no difference between those two situations. Now, imagine you are shooting a light beam in this elevator that's accelerating without gravity. You're in the elevator, and as you shoot this light beam, the light beam's going to wants to go across, but because, let's see if we can do it from here, because as the light beam comes like this, the floor of the elevator is rising, that from your point of view, it looks like the light beam is actually, curving downwards because the floor of the elevator is coming up. So, if there's no difference between the accelerated frame and a gravitational field, and in the accelerated frame, the light, from your point of view, goes down, then Einstein then took the next step and said, well, gravitational fields cause light to bend down also. And the question is, how does it do it? Well, he then took, and then that final step in the initial concept is that he speculated that gravity or masses cause space to warp itself, and that causes the curving of light. That is the essence of what he came up with in 1905. It took 10 more years in order to solidify the math around that, but 1905, that was a big year for Einstein. That was one of 4 major papers that he wrote. Any one of those 4 actually could have earned him actually 3 of them could have earned him a Nobel Prize, which he ultimately ended up for the photoelectric effect plus contributions to physics. So there it is, general relativity in a nutshell. The math gets into tensor calculus, and that's a different lecture.